Hello viewers, welcome to the lecture series on CAN protocol. In this video, we are going to see CAN encoding, synchronization and bit stuffing. So let's get started. First, we shall see the encoding format used in CAN protocol. CAN protocol basically uses non-return to zero encoding, which means symbol 0 is transmitted as low and signal 1 is transmitted as high. That is in NRZ encoding, the signal is constant for the whole time period or whole bit period. Hence only one time segment is needed to represent one bit. No multiple time segments are required to represent a single bit. Hence one bit, single time segment. A 0 corresponds to the dominant bit, placing the bus in the dominant state, and 1 corresponds to the recessive bit, placing the bus in the recessive state. But some of the problems that arise using the NRZ encoding includes a long sequence of bits of the same polarity results in no changes in the voltage level for long duration of time. Due to the above reason, there is no falling edge for synchronization. As you know in my previous videos, falling edge in the start of the frame results in hard synchronization. But due to the long sequence of either dominant or recessive bit, there is no falling edge, hence there is no chance for synchronization. As the result, there may be loss of synchronization between sender and receiver. This is the problem arises due to the usage of NRZ encoding. In order to overcome, it uses bit stuffing. So what bit stuffing does is, it is used to ensure the synchronization of all the bus nodes. During the transmission of the message, a maximum of 5 consecutive bits may have same priority. Guys, here 5 consecutive bits, it may be either in dominant state or in the receiver state. For example, you can observe here, say this portion, that is red and green, has a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dominant state, that is 0 level. Hence, after each 5 states, a bit is stuffed. For 0, the logical 1 is stuffed. And see, for same thing, for next case, purple and black has 10 recessive bits, that is logic 1. Hence, after 5 consecutive bit state, a logical 0 is stuffed. That is what the transmitter will insert one additional bit of the opposite polarity into the bit stream before transmitting further bits. That is, for consecutive sequence of large sequence of dominant bits, a recessive bit is bit stuffed. For a recessive bit, a dominant bit is stuffed after 5 consecutive cycle. But say this is done by the transmitter. The receiver also checks the number of bits with the same polarity and removes the stuffed bit again from the bit stuffing. This is called as destuffing. See, after 5 consecutive bits of the same polarity, insert one bit to the reverse polarity. That is summarizing. CRC code is calculated before bit stuffing is done. So before bit stuffing, we calculate the CRC code. Bit stuffing is done by the sender directly before transmitting. Destuffing is done by the receiver directly after reception. So CRC code check is done after destuffing of the frame. Bit stuffing is applied to the part of the frame from start of the frame to the CRC field. So let us see an example. There are 3 examples provided. See here, 1, 2, 3, 4, 5, 6. In this bit sequence, there are 6 dominant bit. Hence, after every 5 dominant bit, a recessive bit is stuffed. For the same here also, for a 5 dominant bit, a recessive bit is stuffed. In this case, guys, you see here, after 5 dominant bit, a recessive bit is stuffed. See, in the original signal, there are 4 recessive bit. So after stuffing, this results in an 5 sequence of recessive bit. Hence, a dominant bit is stuffed. Next, coming to the bus synchronization, can handle message transfer synchronously. All nodes are synchronized at the beginning of each of the message with the first falling edge of the frame which belongs to the start of the frame, which is called as hard synchronization, as I explained earlier. So on the falling edge of the start of the frame, all the nodes will synchronize. That is known as hard synchronization. And to ensure correct sampling up of the last bit, up to the last bit it is correctly sampled, the CAN nodes always need to resynchronize throughout the entire frame period. This is done on each recessive to dominant edge. I hope this was useful. Keep subscribing to the TUS class. Have a